In our last video, we were looking at how to solve logarithmic functions in a word problem, and we ended with talking about how to graph them. So here we're going to go in more detail on graphing them and then actually graph a logarithmic function. But before we get to that, let's look at what the transformations of a logarithmic function look like. So we have g of x, which is referring to the transformation of a logarithmic function. So g of x equaling a times log base b of x minus h plus k. Now some of this should look familiar because this is the same format you would have when you were dealing with transformations in quadratic or absolute value functions. H is our horizontal movement translation, k is our vertical translation, a is our dilation. And if there's a negative involved with our a, then there is a reflection involved. Okay, so let's take a look at an example. We want to graph the function and then find the key features. Now, you could put this on your graphing calculator if you can change the base. In a later lesson, we will look at graphing with change of base. But for this one, if you don't have a graphing calculator, keep this simple. And you keep it simple by changing this to an exponential function. So really, this would be base 6 of, so really my f of x is equal to 6 raised to the y power equals my x term, which is here. All I need to do is choose numbers for my y value to find my x. So I'm going to keep this real basic, ones that you can easily do in your head and to be able to graph it. So this is our x and this is our y. So I'm choosing my y values. And I'm always going to choose -1, 0, and 1 because those are ones I can do quickly in my head. So 6 to the negative first power, negative exponent means I flip the base, so that would be 1/6. Anything to the 0 power is 1. So 6 to the 0 power is 1. And then I have 6 to the first power. 6 to the first power, anything to the first power is itself. So this will give us 6. Now the first thing I'm going to do is put down my asymptote. And since I'm graphing a logarithm, I'm switching my x and y around. That means I flip my asymptote. My asymptote is now the y-axis. So that means my graph cannot touch that. So now let's put points on. So I have 1/6 and -1. 1/6 and -1 would be somewhere close to there. Then I have 1, 0. And then I have 6, 1. Now, if I wanted to put my reflection line in here, I could put the reflection line right here. There's a reflection line. And now if I were to graph this, it comes along the asymptote, gets close, crosses the x-axis there, and then it just continues there. So there would be my graph of the logarithmic function log of base 6 of x. Now let's find the key features. So here you have the same graph that we had, which is very similar to what I have there. And let's just describe the key features here. So the x-intercept. The x-intercept here is 1, 0. I don't have a y-intercept because the asymptote is now the y-axis. The domain. You'll notice that I never go to the past 0 or to 0 on the domain. So they have this as order pairs. So I have a 0, which just means it can't equal 0, and then it goes to positive infinity. Or you could just say that the domain is x is greater than 0. The range, you can see that it continues to go up and it continues to go down. So we would say negative infinity to positive infinity, or you could say y is all real numbers. The asymptote is the y-axis, or you could say x equaling 0. It's increasing all values of x. Just means when I go from left to right, it's always increasing. This one's never decreasing from left to right. It's positive. It's above the x-axis when x is greater than 1. So I'm just looking at the x-intercept. When I go to the right of the x-intercept, it's above the x-axis. And it's negative when x is less than 1, but when it's greater than 0. Because again, it doesn't go past 0. And then the end behavior, as x approaches 0 from the positive side. That means when I go to the left, I'm approaching 0. F of x approaches negative infinity. And as x approaches positive infinity, so when I go to the right, my y value approaches positive infinity. It keeps on increasing. Next, graph this function. Graph g of x is equal to the log base 1/4 of x. So if I draw a table, or if I rewrite this, this would be saying 1/4 to the y power is equal to x. And I want to draw a table of values here. Again, this is my x, this is my y. I'm choosing y values. Again, I'm choosing the same 3 numbers. 1/4 to the negative first power. I flip the 1/4 and raise it to the first power, and I get 4. 1/4 to the 0 power is 1. And 1/4 to the first power is 1/4. So now to graph this, I'm going to put my asymptote in first. So let me do that better. So this would be my asymptote line. And then I'm going to put my reflection line in here. Do you have to put the reflection line? No, you don't have to put the reflection line in there. So now I just plot the points. 4, -1. So 4, -1 is here. 1, 0 is here. And then 1/4, 1. Which would be right here. Let me get rid of my reflection line here. And now I can draw my graph in here. So it comes down here, crosses the x-axis. So this is a decay because I have a base of 1/4, so that means it's going down from left to right. So there I would have a reflection over there, and the reflection on this one would just be going across here. So it just flips it up like that. So now let's do the key features. So the key features, the domain, or the x-intercept stays the same as 1, 0. I don't have a y-intercept. The domain, again, this would be 0 on the low end, positive infinity on the right side, or you could just say x is greater than 0. The range is all real, or you can do negative infinity to positive infinity. The asymptote, x is equal to 0. It's increasing. It's never increasing from left to right. It's only decreasing for all values of x. Positive. When is it positive? So based on the x-intercept, it's above the x-axis when x is greater than 0, but less than 1. And it's below the x-axis when x is greater than 1. And the end behavior, as x approaches 0 from the positive side. So when I go to the right, or go to the left, my f of x, my y, approaches positive infinity. And as x approaches positive infinity, when I go to the right, y approaches negative infinity. Next one, here we're going to graph log base 3 of x. So this would be saying 3 to the y power is equal to x. Again, draw our table of values. This is my x and my y. I choose y values of -1, 0, and 1. 3 to the negative first power is 1/3. 3 to the 0 power, or yeah, 3 to the 0 power is 1. 3 to the first power is 3. I'm going to draw my asymptote line in. Okay, then I plot the points 1/3 and -1. So 1/3, -1. There, 1, 0 here, then 3, 1 would be here. And then I can draw my line. Comes up, crosses here. And the key features, again, there's our graph again. X-intercept, 1, 0. No y-intercept. The domain, I'm just going to say x is greater than 0. The range is all real. The asymptote is x equaling 0. Increasing, it's always increasing from left to right, so all values of x. It's never decreasing. It's positive based on this x-intercept. It's positive when x is greater than 1, but it's negative when x is greater than 0, but less than 1. And as x approaches 0 from the positive side, y approaches negative infinity. And as x approaches positive infinity, when I go to the right, f of x approaches positive infinity. This one, graph this log base 1/8 of x. So again, this is 1/8 raised to the y power equals x. Draw a table of values. My x and my y. Again, I choose -1, 0, and 1. 1/8 to the negative first power is 8. 1/8 to the 0 power is 1. And 1/8 to the first power is 1/8. Okay, I'm going to draw my asymptote line again. So I have a point at 8, -1. Put that in the wrong spots. So 8, -1 is here. We got 1, 0. And then 1/8, 1 here. Then we can draw our line. So it comes down, crosses the x-axis, and comes this way. The intercepts now, x-intercept again is still 1, 0. There's no y-intercept. The domain, x is greater than 0. The range is all real. The asymptote, x is equal to 0. Increasing, it's never increasing, it's going down from left to right. So this is decreasing all values of x. Positive, based on the x-intercept, it's above the x-axis when x is greater than 0, but less than 1. And it's below the x-axis when x is greater than 1. And then when I approach 0, from the positive side, f of x approaches positive infinity. And as x approaches positive infinity, y approaches negative infinity. And our next part, we're going to look at modeling that with word problems, but I'm going to do that in